Okay, on this problem, you're told that 14% of people are left-handed and you select 3 people at random. And then you have 3 questions. How many lefties do you expect? With what standard deviation? And if we keep picking people until we find a lefty, how long do you expect it will take? So one thing that I want you to pay attention to in this question is this idea of expectation. You see it twice, and in statistics, when we're looking for what the expectation is, that's really asking for the mean or the average. We're wondering, on average, how often is this going to happen, or what can we expect if we were to do this over and over again? Now, this is an example of a Bernoulli trial because you are either left-handed or you are not. So in this case, the 14% is our P. 14% of the people are left-handed, and so clearly, in order to compute how many people are right-handed, you could just, I'm going to come into the cell here, and I'm going to put 0.14 for P, and then your Q will be just 1 minus 0.14 equal sign 1 minus, and then you can click on that cell and it'll give you the answer of 0.86. So question A says, how many lefties do you expect? So we are dealing with a Bernoulli trial. The two models that we talked about with a Bernoulli trial are either the geometric model or the binomial model, and it depends on what the question is saying. But in this question it says we select 4 people at random, so we have a fixed number of trials, which is why it is a binomial model. A binomial model tells us the probability for a random variable that counts the number of successes in a fixed number of trials. In this case we have 4. So the expectation, how many lefties do you expect in the binomial, is what is the mean for the binomial. The mean for the binomial is n times p. So you just take the number in the trial, which here is 4, and multiply by the probability of success, which here is p. So coming back up here, and let me switch back to, and we might want to put what n was here. N here, we remember, was 4 because they're doing 4 trials. So how many lefties do you expect? That's going to be equal sign n, which is 4, or is in 01, times the probability of a success, which was the 0.14. So that's how many lefties we would expect if we, not very many, right, if we only select 4 people. With what standard deviation? Again, look at the binomial model. The standard deviation, the formula for standard deviation is right here. That's the sigma, is standard deviation. So these Greek letters, remember, the mu is mean or expectation, and this sigma, that little Greek letter there, that's standard deviation. And so we'll come in here to Excel, and we will just do, in this cell right here, we're looking for the formula for standard deviation is square root of n times p times q, so you'll do equal sign. The square root in Excel is the command SQU. If you start typing it, you'll see it RT, and then you want to do n times p, which is the 0.14, it lives in O2, times q, which is the O3, in O3 here, and we'll hit enter. All right, so 0.69 is our standard deviation. Now finally, on part C, they're mixing it up for us. It says if we keep picking people until we find a lefty, how long do you expect it will take? All right, now they've changed the model, because what we're going to do is we're no longer going to just pick 4 people, we're going to keep picking people until we find a lefty. Well, that is the example of a geometric model, because a geometric model tells us the probability for a random variable that counts the number of trials until the first success. They want to know how long we expect that to take. Again, expectation is the mean, or the mu. So we just have to do 1 divided by p. That's the formula. So we'll take, we'll come over here in part C, we'll do equal sign 1 divided by our P, which is here, is the 0.14, which lives in cell O2. And I'll click enter. So we would expect to have to pick 7 people until, I think they want it rounded to 2 decimal places, so 7.14 people before we would find a lefty.